How do you figure out percents of anything?
Yeah. Something over on.
Or like, I don't know, I guess I'm just biased to this, but I always think of like free throw percentage, like how well my team shoots free throws. How would I figure out my team's free throw percentage?
Take the total number of free throws made and the total number attempted.
So let's say out of 100 free throws, you know, we hit 70 of them. What's the percent that we made?
70%.
How do you know that?
You divide 70 by 100.
Good. So you know it because that's easy numbers, right? You know 70 divided by 100 is 70%. But when it comes to percents, really all you're doing is part over whole times 100. I kind of left that out. If I give you more obscure numbers, let's say we shoot 50 and we hit 28. It's harder to do that in your head. So you would go on the calculator, you would say, all right, 28 divided by 50 times 100, that would be the percentage. Okay, it's a little less than 60%, right? What is it?
I just did that in my head. That's 56%.
Yeah, 56%. Very good. Yeah, you can as you get older. Kyle's good right now, obviously, but as you get older, you can get better doing percentages. Why? Because you buy things, you shop. Sales, people who buy things on sale, you should be able to do those things in your head. So if something's like $49.99, so $50, but it's 20% off, you should be able to do that in your head. Now you could use a calculator on your phone, I suppose, but you should be able to take 20% of 50 and then subtract it. So that's something you get better at as you get older. But in here, that's what we're doing. Percent composition means, stay with me, percent composition means part over whole times 100. So I don't really have a whole lot of time to reteach percents, but that's just my little spiel on it, okay? So I think we'll start with that today because it's not too bad to do, and then we'll work our way through this list. And then next week, probably at the end of next week, a little quiz will be on all this. Maybe like one of these, a couple of those. So whatever, 10, 15 question quiz just on this stuff. Okay. All right. You probably won't have another big test for a while. All right. Questions before we move on? Okay. So we'll start with percent composition. All right. So I'm just going to start off with a sample problem because that's the best way to learn it here. So if you want to retitle it, you can. Percent composition problems. So here's a sample problem. Calculate the percent by mass of nitrogen in KNO3. Calculate the percent of nitrogen, of N, in the compound KNO3. Oh, I just forgot I wanted to go over the gummy bear there. We'll do this first, then I'll talk about that. I want to make sure you understand the reaction. So I'll give you a couple minutes, few minutes, see if you can figure it out. Show your work. And if you're confused with that part over whole times 100 business, it's on the back of the reference tables if you want to take those out. It's on the back of the reference tables. In fact, all of the formulas we just listed, moles to grams, grams to moles, percent composition, molarity and parts per million, all the equations are on the back of your reference table. So again, show, yes. Okay, you can grab it. So again, part over whole times 100, show your work. Round your answer to the, let's say, tenths. Round your answer to the tenths. Make sure you label your answer, right? If it's a percent, you should put the percent sign after it. And get in the habit of boxing or circling your answers. I have an AP student this year who shall not be named, who just kept forgetting to do that, put boxes and circles around his final answer, and I kept saying you need to do that or I'm going to start taking points off because I can't find the answer. It's too hard. Took him a little while, but he finally caught on.
What do you honestly have to?
Tenths. Oh yeah, don't forget I gave you this sheet here. You want to review this before the quiz tomorrow? Some point today? Tonight? Whatever. Okay, we have notes on it, but this is a nice little cheat sheet for the courses. Thanks, Leah, for sharing that with me. You see that word, right? Where we calculate percent by mass. So this whole thing has a mass, and then that's the whole number. So mass of whole, mass of part would be just the mass of the end. Now, I didn't give you any mass numbers, so where do you think you're going to get the mass from? Yeah, figure out the table. So I did not give you any mass numbers. It is.
Those are they're terrible.
Oh, can you put the phone somewhere else, please? Okay. 13.8 or 13.9? I see both answers. Let's see.
13.86.
So K is 39, N is 14, O is 48. Now, I want to clarify this before someone asks. Sometimes students will say, wait a second, N is diatomic, so shouldn't that be N2? The only time the little 2 factors in is when the elements are by themselves. It's called the elemental state. When it's in a compound, doesn't matter. Okay, it doesn't matter that it's diatomic or not. Sometimes it has a 2, sometimes a 3, sometimes just 1. So don't let the diatomic confuse you. That's only when elements are by themselves. So right here, it's just N. So when we do percent composition, 14 is the number, 14 is the number on top. It's just one N. That's all we have, one N. Okay, 1K, 1 N, 3 O's. Now the bottom number is if we add all 3 up, what is that, 101? 101 grams per mole. We don't need the per mole part, we just need the 101. Okay, because really this is 14 grams per mole divided by 101 grams per mole, but we can just use grams. We don't need the mole part for this one. Because really it's just a proportion, just a ratio of 14 to 101. So with percent composition, you're kind of doing a ratio or a proportion with just grams. I think I heard Morgan Thomas say something like this is what she initially said when I said, how do you figure out percents? That works too, okay? I think is that what you said? Yeah, so that works too. I do part over whole times 100. It's literally the same math. But this is just how I do it. It's on your reference tables as well on the back. So that's part over whole times 100. So however you want to do it, I'm fine with it as long as you understand how to get the percent. So anyways, we do this, and 13.9% is the answer. That's a pretty typical percent composition problem. Questions? Okay, we'll give you one more. If we get cut off by the bell, then we'll just pick up with this tomorrow. And again, I don't have a sheet for you, so maybe I'll just have you work on it after the quiz since I won't be here period 7. I may give you the sheet in class tomorrow and have you work on it in class. It'd be easier since I'm not going to be here later. I don't know, we'll see. But all right, so what if I gave you this problem here? Hold on. I didn't get my notes out, so I'm going on the fly here. Aha. All right. The compound. Oh, sorry, not the. Sorry, I'm trying to do this here off the top of my head. Sorry. An unknown compound with a mass of 158 grams. Yep. Has an element with a percent by mass of 34.8%. Calculate the mass of that element. An unknown compound with a mass of 158 grams has an element. I should probably change contains. That would be a more scientific word. Contains an element with a percent by mass of 34.8%. Calculate the mass of the element. I'm actually having you do this because it trains you or gives you a little warm-up for something down the road with another equation. So just copy it down, then you are free to go, obviously. Oh, sorry.
Right in front of it.
Got a lot of sass today, you know what?